This is the 3.4 notes for graphing from standard form. Your objective is that you can graph from standard form. A couple terms that we need to know to get started. The first is standard form. What is standard form? Standard form has an appearance of ax plus by equals c. The kind of big thing with this is there are no fractions, and a must be positive. The next one we have is our x-intercept. The x-intercept is when y equals 0. This is where the graph crosses the x-axis. The x-axis. The y-intercept, in contrast to the x-intercept, is when x equals 0. And this is where the graph crosses the y-axis. A little example is provided. This is our y-intercept. And this is our x-intercept. Okay. All right. A couple things to look at. Horizontal and vertical lines. A horizontal line on a graph, I'll have to change colors just so you can kind of see this. So if this is a normal graph and I have a line that goes like this, this is y equaling a number, and we're going to say b. Alternatively, on another one, a vertical line, this is x equaling b, or a. We'll use a. Okay. All right. In examples 1 and 2, we're going to graph the linear equation. So if I make a little graph, so for number 1, we have y equals -3. And this winds up being a, if you look at it, y equals -3, this is a horizontal line, because we're at -3. Y is -3, and y is always -3. It's nothing but -3. And our y-intercept is at -3. Number 2, if we have a graph with totally straight lines, and our equation says x equals 2, our graph is at 2, and it's always at 2. Okay. Put it down right there. Alright, now in examples 3 and 5, find the x and y intercepts of the graph of the linear equation. Oops. Okay. So for number 3, we're given 3x plus 4y equals 12. So finding the x and y intercepts can actually be a little bit like a lot easier than you kind of probably are making it out to be. So to find an x-intercept, we know that for every x-intercept, the y has to be 0. And that's kind of the trick to this. And so what we go is 3x plus 4, and instead of y, we put in 0. We say that equals 12. And what's nice about this is multiplying by 0 is probably one of the best things to multiply because it just gets rid of it. And so I get 3x equals 12. and now I divide by 3. And so I get x equals 4. And so I can fill in 4. Maybe I'm going to, for people that just look at this, that gives us that. All right, now I'm going to use the y-intercept. And again, we already know one of these numbers. It's the x. The x is going to be 0. And so I go, all right, 3 times 0 plus 4y equals 12. And you can probably already guess what this one's going to be. The 3 cancels out, and so I'm left with 4y equals 12. I divide both sides by 4, and I get y equals 3. I take that, and I plug it in, and that gives me my y-intercept. Number 4 is going to work almost exactly the same, except we have slightly different numbers. So I have negative x minus 4y equals 16. If I want my x-intercept, I'm going to set my y equal to 0. And for my y-intercept, I'm going to set my x equal to 0. Oops, not x. I'm going to set my x equal to 0. And I'm going to only do one at a time, but that way I kind of remember which one to do with which. And so I do negative x minus 4 times 0 equals 16. So I get negative x equals 16. So my x equals negative 16. So I can fill it in, negative 16. My y-intercept, I'm going to have negative 0 minus 4y equals 16. Negative 0 makes 0, so I have negative 4y equals 16. I'm going to divide both sides by negative 4 and get y equals, negative 4. So my y-intercept is negative 4. Do number 5. If you think you have it, go ahead and pause it right here, see if you can do it. We're going to continue on though. 5x minus 2y equals negative 30. My x-intercept, I don't know what the x is. I know that my y is 0 though. And for my y-intercept, I don't know what my y is, but I know that my x is 0. So I do 5x minus 2 times 0 equals negative 30. And so I get 5x equals negative 30. Divide both sides by 5. And I get x equals negative 6. Alright, for the y-intercept, I'm going to go 5 times 0 minus 2y equals negative 30. Oops, plug in negative 6 here. Then I go, alright, negative 2y equals negative 30, and divide both sides by negative 2. And I get y equals 15. 15. In examples 6 and 7, use intercepts to graph the linear equation. Label the points corresponding to the intercepts. So number 6 and number 7, to graph a line you only need 2 points, and kind of sometimes a lot of the best ones to choose are the x and y intercept. Again, because you get to work with 0. So if I have negative 8x plus 12y equals 24, I'm going to set it up almost exactly like I did before, so that then I can calculate the x and y intercepts. So the x-intercept, I don't know my x, but I know my y is 0. And for my y-intercept, I know my x, but I don't know my y. And so whenever I do this, I get negative 8x plus 12 times 0 equals 24. So negative 8x equals 24. Divide by negative 8. Divide by negative 8. I get x equals negative 3. So I know this is negative 3. For the y-intercept, I go negative 8 times 0 plus 12y equals 24. This leaves me with 12y equals 24. I divide both sides by 12 and I get y equals 2. So on my graph, I can graph these 2 points and I'll have an answer. So negative 3, 0, so 1, 2, 3, 0, there's one spot. 0, 2, I go up 2, just like that, and then I connect the lines, just like that. Alright, number 7. 2x plus y equals 4. Again, I'm going to get my x-intercept, which I don't know the y value, or I don't know the x value, but I know the y value is 0. And my y-intercept, where I know my x value is 0, but I don't know my y. So in solving this, I go, okay, 2x plus 0 equals 4. I get 2x equals 4, so I get x equals 2. For my y-intercept, 2 times 0 equals y. Oops, getting a little ahead of myself there. 2 times 0 plus y equals 4, so I get y equals 4. And so I can graph this. So 2, 0, 1, 2, 0, and 0, 4. 0, 1, 2, 3, 4. And I can graph this. It comes down like that, in a straight line, of course. And that completes graphing from standard form. Check with your teacher on what your assignment is. Have a good one.